Next out of the 2.6 notes, again, we're trying to combine what we've learned previously with what we're learning currently, taking a look at those piecewise functions and how absolute values kind of fit in, both writing an absolute value as piecewise, but now also including absolute values in piecewise functions. So we're going back in time, we're taking a look and considering the fact that here I would have one specific interval, and that's going to be at an x value of 0. So that means that whenever we change these pieces, when we start worrying about going from one to the other, it's going to be at that green line, that interval, in this case, 0. So first line that I want to graph will be the one that is going to be 2x minus 3. That's a linear equation. Like usual, I want to graph the y-intercept first, so I'll go ahead and draw a dot on the y-intercept. But it is on that green interval, and I notice that arrow does not have a line underneath it, so I might as well draw an open circle already because it's going to be an excluded point. Now, if I were to go up 2 and write 1 like the slope tells me, and I keep on doing that, I can do those things, but understand that that's on the wrong side of the interval. So those points that I just drew right there aren't going to be in the final product. I can go in the opposite direction, and that's probably a little bit better of an idea. So I'm going to do that, and it does go off to infinity. So I have my dots connected right there, and I can go ahead and erase those lines because, again, those things aren't going to be a part of this situation. They are on the wrong side of the interval. Finally, I want to graph the absolute value function here, and in this case, we have the absolute value of x minus 2 plus 1. This is a good reminder, good practice. All right, what do I have going on here? I have an a value of 1. I have an h value of not negative 2, but it's positive 2. What would zero out the bracket? And then k would be 1. So the first dot that's getting drawn here is actually going to be at 2, 1. So I'll go ahead and draw that dot right there. I know that I have a mirror at that location, and I have an a value of positive 1. So for a moment, I'm going to consider the fact that that mirror is right there. I will eventually erase that and the green line, but just for holding purposes here. So I'm going to go up 1 from that location to the right one, just like the slope told me to. And all of those are fantastic, but all of those also would have a mirror location on the other side. So I will start to mirror those points equidistant. I come to this spot right there, and now if I drew one more dot, or maybe 2 more dots right there, those last 2 dots aren't going to be part of this image, this final product, because they are on the wrong side of the interval. We're talking about x values that are smaller than 0, and that's just not what we're doing right now. So I'm going to go ahead and erase those last 2 dots. I'm going to understand that this one on the y-axis is included because the line's underneath. And I'll be able to draw that right there. Now, depending on how you like with highlighting, you don't have to get rid of those, but in case you wanted to see a clearer image of this last thing, we'll go ahead and finish it up like that. We see the excluded and the included dot at that x value of 0. We're able to have this, and that absolute value kind of looks a little weird. We don't completely see the mirror there, but of course we got cut off at the interval. So we're able to combine that concept and graph absolute value functions as part of piecewise functions as a callback to the previous topic.